Well, good morning, everybody. I want to start off with a quick correction on yesterday's video. I showed you this calendar yesterday put together by Iowa State. It's their Mesonet site, and it shows the every day of the year and the level of risk from the Storm Prediction Center we've had for severe storms on those days. And I had mentioned that since June 8th, we'd had a slight risk every single day until yesterday. And I even put it in the title, like streak ended. Well, about 2 hours after I released the video, the Storm Prediction Center changed their maps, which they do constantly. That's a sign of a good forecasting system. And they showed that the severe storms that were coming out of parts of Nebraska into western Iowa, getting into Missouri, they needed to build a slight risk ahead of that as it was diving farther to the south. And then a couple places east, they needed to increase the risk of severe storms. So now we continue that streak, right? And we do have over the next 3 days at least a slight risk. So again, from June 8th all the way to present and the next 3 days, we're just going to continue this risk of severe weather. Yesterday's storm reports kind of show the scattered nature of the storms. Remember, our pattern is kind of favoring a larger ridge that's here, that's opening to the east, but there is still a trough of low pressure sitting here, so the flow's still kind of coming around like this. And wherever we have that kind of convergent surface air, we just get a lot of rising motion in these particular areas. Plenty of triggers in the atmosphere to get these storms to pop. A lot of them produced straight line wind damage and hail yesterday. Okay, really quickly, at the end of this video, if you just want to fast forward to it, I have new long range update stuff I'd like to talk with you about, including what seems to be finally the first signs that El Nino is really getting involved in this pattern. And then I also covered some international updates I think you might find interesting. But in the near term, I want to come back and just show you some satellite data. Here's the sun rising in the middle of the country this morning. If I take you back to yesterday, I just want to show you the trajectory of these storms. You can see that coming out of the upper Midwest, a lot of big storm cells popping. We had a big complex of storms that rolled through parts of the eastern Corn Belt, and then isolated severe storms up the east. So as far south, bigger storms down here in North Carolina, which has been hit multiple times in the last 48 hours. And then you can also see some of the bigger storm complexes in the east. Still have the Canadian wildfire smoke. We can also see some of the smoke getting mixed in here in parts of the Pacific Northwest. But this ridge, which had been parked a bit farther to the west, is beginning to open east, and we need to talk about what that's going to do. But I also want to point out we did have a front bringing in some cooler weather here into parts of the northwest, including some cloud cover. And we're going to see here in a few moments if the models have stayed consistent with the return of heat to the west once we get past about the next 6 to 7 days. So that's the start. This is where we kind of dig into the pattern. Now, what we're watching for very carefully whenever there's a larger ridge to the south like this is we look for these very subtle little short waves. You hear me say that a lot, short waves versus long waves. You can kind of get a sense of the longer wave pattern by looking at something like this. But if we look and find these individual little waves that move around it, they often initiate rising motion in the atmosphere. They do it through upper level cooling, which is then replaced with some latent heating, which then translates into rising motion in the atmosphere. The net effect is every time we get little wiggles like this in the atmosphere, out ahead of it we watch for falling heights and therefore rising motion. That's just the way it kind of stitches together. So when we see these running over the top of a ridge, they tend to follow the general flow, the longer wave flow. And if they're going to be diving into unstable air, then we're going to produce some big storm complexes out of that. So it is short waves running over the ridge into unstable air that give you ridge riding storms, all right? So if we look today, we're going to keep a very close eye here on the upper Midwest and parts of the northern plains. We're also going to be watching parts of the mid-Atlantic for these storms as well. Going into tomorrow, this would be day 2, 726. We're going to watch as that wave that's running over the top gets over here into parts of the Ohio Valley and the eastern Great Lakes. And it's important to note that they've shifted this risk a bit farther to the north because we do have a bit of a nose of much warmer conditions pulling in here. And that's going to produce kind of a we call it a cap. It's a capping inversion. It's too warm in the low levels of the atmosphere, about 700 millibars, to punch through and make big storms. So they've kind of readjusted this a bit farther to the north and east, but they have an enhanced risk out for northern Indiana, Ohio, southern Michigan, getting over to Lake Erie. And then as we go into the day here on the 27th, we're going to watch this section in New England, and we're even going to see the atmosphere kind of reload a bit as the ridge opens up here to make those storms. Now, to show you this in action, it's very subtle, but this is it, okay? What I'm going to be watching for is, here's the big ridge right there. Now, do you see this shading that I'm circling right here? That's representing something called vorticity. That's cyclonic or counterclockwise spin in the atmosphere. It's much easier to see in the deep low over the Hudson Bay. Now, what we watch is for these very subtle, just keep your eye on this one right here. this very subtle feature, that shortwave, to sneak through Montana, and by tonight, this afternoon, getting here, lining up with the Red River Valley and south. And then we're going to go into the overnight hours. This is tonight, getting into tomorrow morning, tomorrow about midday here. And do you see where it is? There's your shortwave. So the risk tomorrow is in this area. And we're going to keep an eye on that guy again. And it just dives here. And by the time we get into Thursday, where is it? It's over here in New England. All along the way, it's what's initiating the storms. So now that you've seen that, watch as I play the rest of it quickly. Do you notice that running over the ridge, you just watch right here, several little ribbons of vorticity just continue. Watch, go backward and forward. They continue to just cascade over the top of that ridge. This is the definition of a ridge riding setup. That's what it is. That's the lift. Now we have to understand where the instability comes from and where the moisture comes from. So later on today, by 1 o'clock, everywhere that you see inside of this black contour line here, the dew point temperatures are going to be above 70 Fahrenheit. That is, by human standards, disgusting. They're more used to it in the southeast, but you get up this far north, that's really, really hot and very humid conditions. So this is the unstable air that's going to provide the energy, the moisture. This is where it's the conversion of the vapor into a liquid, right? That condensation process that releases a tremendous amount of heat to get this plume of air to rise. It's just all about buoyancy, and it fires it up into the atmosphere, and they blow up into storms. So that was through Tuesday. Now look where the axis is, the moist axis is on Wednesday. And then we go from there into Thursday, and it pushes farther east. But this whole time, we're going to have to wait until we get through the weekend to really start to suppress the incredibly hot and humid conditions that are throughout the Midwest and force them farther to the south. This is a front coming through this weekend that drives that drier air in and pushes the more moist air to the south. Now, the whole time, the desert's very easy to find, very low dew point temperatures, very low humidity out here. But you can see that the culprit for the storm systems that are rolling through this particular area. So now you know why the models want to just generate storms here. So watch, let's just start this off Tuesday at 7 a.m. I just want you to watch this corridor. Okay, that's where the shortwave is going to track. That's where the unstable air is going to be. That's where the moisture is going to be. So here are the storm complexes the model generates over the next 3 days. Okay? Now, it does not mean there won't be storms outside of this. There's plenty of unstable air, and there's plenty of pockets where you'll get convection. That's just the sun heating the ground preferentially and making warm bubbles pop. Okay, you've got all that throughout the southeast. We're going to have storms that come off of the Rocky Mountains. I mean, they're just a great generator of storms this time of year. And we're just going to continue to see that pattern as we go forward, which is why the newest update from the WPC just shows a corridor. Can you see it? Of stormy activity. The unfortunate part of this is the closer you are to the ridge, the more you shut down the ability for the atmosphere to produce convective events by introducing too much warm air in the mid-levels of the atmosphere, which inhibits rising motion from convective events. So this is where we get extremely hot and extremely dry, and the drought gets really quite bad. I'll tell you, throughout the mountains here, I am concerned of flooding in the mountains given this time of year. We can often get some of these to put down inches of rain in minutes. So please keep an eye on that if you're in the Four Corner states. And some of the storms that roll through here will be producing straight line wind damage. They'll be producing hail. And it all comes together in parts of New England because that's where the upper level trough that's in this area is going to be pushing it. Now, on the very northern edge of this, you have the combination of the ridge riding and the jet stream. The jet stream is way up here. So there's even more support to be producing storms out of British Columbia and Alberta through Saskatchewan, Manitoba, Ontario, all the way to Quebec. I mean, it's going to be the active corridor. I was talking to my colleague Andrew Pritchard, who focuses a lot on the weather in Canada, and we said most of these storms are likely going to be north of Highway 16. So a lot of it's going to be up here, the northern half of the Canadian prairie. But this setup in the next 7 days, outside of isolated storms in the southeast, that's it. Very dry, though, in the south and drier in the west. So, bigger picture things, probability maps. This is the chance over the next 10 days of grabbing an inch of rain. And if you've been following these videos closely, you've just watched this whole area see improving chances over the next 10 days with each new forecast. We know that this area is expected to stay very active, and I told you I'm very concerned about the risk of flooding in the mountains, especially here in the parts of Colorado. But if we now flip this over to find those really dry areas, this is the probability of less than half of an inch, and this is the probability of less than a tenth of an inch. Now, with this pattern, I want to make one thing very clear. There will be storms in the west, no doubt about it. But this lower resolution ensemble forecasting technique does not resolve them well. So that's why you don't see it here. We just see very dry conditions. The area that I'm most confident on really missing out on a lot of this initially is going to be down here in the southern plains, possibly getting over into the mid-south. All right. Now, the overall pattern is really unchanged as what we've been talking about. We play through this week. See, look, there's where the jet is. That's where the speed of the jet's going to be with this trough. You just go out there through Friday, Saturday, Sunday, and what do we have? Here is the southern side of the cooler air here that's going to be driving in some of that drier air finally by this weekend, late this weekend. But to the south, oppressive heat, just hot, humid conditions. But the ridge, notice where the ridge is going to be by the time we get into Saturday. It continues to show up as a ridge that's going to stay farther to the west. And what it's going to do is, if the ridge axis is here, but this slope is relatively gentle because of where the trough is placed, if you place this trough back over the Hudson Bay, then this ridge would really get swished to the west. What this now tells us is that the heat is going to just stay south. It's going to really occupy a large area across the south rather than being more focused farther back to the west. And it just seems to be that way in the newest forecast models going all the way out there to the beginning of August. So just a difference between what we saw in early July and August is this trough of low pressure is now situated closer to Quebec, whereas in early July it was primarily into this area. So what that's doing here is that's really opening up the chances for more heat to just stay across the south and invade the southeast, which for most of this year most of this spring and summer has been quite cool compared to their averages. It's not cold, but just cool compared to their averages. On the precipitation side of this, look at the week 2. Now, this is going to be something important for us to talk about. First of all, the CPC has no region here in the lower 48 where they've got a risk of being drier than normal. I would make a comment, again, this is week 2, that the area that I would be concerned about not getting that moisture in place is right down here. But certainly running over the periphery of it, I could see lots of storms rolling through this area. Notice that the European model is a bit drier in parts of the upper Midwest as well. I want to keep an eye on this because that would indicate that the depth of this trough, which I told you is over here, is actually introducing a lot more dry air than I initially thought. But I want to talk about this western mountain storm activity, what it could mean for the rest of the country. North to south, we need to talk about this in a few moments. So keep this stuffed away in the back of your mind. As I always say, the wild card is the tropics. We've got a couple of areas to keep an eye on. Okay, we've been watching this wave here for the last, 10 days or so, and it still has a 10% chance of doing something in the Caribbean. We do need to watch a disturbance coming here toward the Carolina coast, toward the Georgia coast, but a lot of indications suggest that whatever comes here makes this hard turn and gets out. You say, why? Well, if we redevelop a trough in this area, there's no reason for that to move on shore. It's got to sneak in completely underneath it. We don't think that that's going to be happening. And that's why when I show you the ensemble probability forecasts, we just come out here and say, what's the chance of getting a tropical depression in the next 10 days? Well, there's this system. There's the one that follows it. And then the risk of something coming in here. But I think the best evidence is for it to kind of pull away from the coast. So we're still buying some time here starting the month of August without, I think, major risk of a hurricane developing. But as we've been discussing, we know how warm the water temperatures are and what they could potentially do to develop a system. So if we start off our temperature discussion with this map, I posted this yesterday on Twitter just to kind of see what folks could say about it. I want to be very clear on what it is. It's a stress degree day map. This is made by adding up any degree over 86 Fahrenheit. And some of the research done out of Iowa only, so this was only applying to Iowa, by Dr. Elwin Taylor, suggested that if you accumulate more than 140 units of stress on temperature, he measured yield losses. And we're not there in the upper Midwest, the East. We've had cool weather so far this summer compared to normal. It is very common to really surpass it down here in the South, but the crop calendar is entirely different in the South, and the crop mix is different. But it has been extremely hot in Texas. So if you just think about it, parts of West Texas have already picked up 1,000 degrees more than of temperature above 86. Does that make sense? So let's just say the temperature today is 90. You would accumulate 4 SDDs. Got it? So the heat in Texas has been unreal. So the question is, with all this heat coming in, because we do have, as of my recording this morning at 6 a.m., the heat advisory stretching farther and farther to the north, okay? Red flag warnings in the Pacific Northwest and parts of the Pacific Northwest, air quality here in the upper Midwest. But as we watch these heat advisories expand, how many STDs are we going to be accumulating? Well, we can do that math pretty quickly here just by looking at the high temperatures. So if you note here that it's going to be 88 today in this part of Iowa, well, we're going to get 2 of them here. See how that's going to work? So as we go from Tuesday into Wednesday first, then Thursday, look at this triple-digit heat coming out of Kansas, clipping Nebraska, Iowa, Illinois. A lot of heat here. Temperatures deep into the 90s, upper 90s in the upper Midwest on Thursday. Going into Friday, still hot, but you can start to see the cooler air coming in. Notice, by the way, this whole time, Pacific Northwest near normal high temperatures. California backed away from the excessive heat. The heat then moves east. It's into New England on the day on Friday, but there is that front that's coming through. This is the one that clears things out Saturday into Sunday. That brings in the drier air, and it brings in just near normal seasonable temperatures here, while the oppressive heat stays farther to the south. And that's where I'm going to be concerned about it sitting in the near term, because the newest update from the CBC, which confirms this, just shows that there's the risk for excessive heat across the whole of the south from now through about the 4th or 5th of August. So let's watch this carefully. Our 5-day window of 5-day sliding window of average temperature anomalies shows the ridge retrograding by day 10. You can see the heat that's going to be still tucked into place down here, but the cooler air coming in to the Great Lakes area and east. And then we just watch as we play into the beginning of August. We start to see things kind of stay hot west, stay hot south, but not retain the heat in the midsection of the country. Okay, that's your near term. I told you I had some long-term stuff on this I really wanted to talk about. It begins with the Southern Oscillation Index. We talked about this a bit yesterday. You got to have a very negative value of the Southern Oscillation Index to say you're in El Niño. And our Southern Oscillation Index has just been going up and up and up, which means El Niño not engaged. But lately, in the last 3 days, it's starting to make this turn down. And there is some evidence that it's going to continue to do that. We see that there is better chances of the velocity potentials going negative, stretching here out in the Pacific Ocean. Also a reflection over here in the Indian Ocean and near Africa. Now, we always watch these for the initiation of tropical systems coming off of Africa. It's very common to see this when El Niño takes over. But this, right in through here, shows me there's going to be better rising motion coming out here into phases 7 and 8. This is not a full-blown shift to the MJO, but there's some rising motion here. That's what a negative velocity potential means. We're looking at how the tropics are breathing. The next thing is this. Whenever we have an El Niño going, a strong one, we tend to see a lot of these warmer colors in the Pacific Ocean indicating stronger westerly wind bursts. So this is stronger winds coming out of the west against the typical trade wind direction, which is from the east. And that's what El Niño does. So there's that indicator. We then look a little farther and we notice that lately these ocean temperatures have gotten colder. Warmer. Get that right. And we've kept this up here almost a degree Celsius above average. We're well over 5 degrees Celsius above average here. We talked about this yesterday. Now, with all of these signs, I want to know if the atmosphere is going to respond to better rising motion here, warmer ocean temperatures here, Southern Oscillation Index dropping. And we're starting to see that in the jet stream behavior. Now, this is really important for really the next 5 to 10 months. You see, whenever we have an El Niño, its most telltale sign in jet stream behavior, or maybe I should say the first thing it's going to do, is this. Now you're looking down on the North Pole, and what that is that's called the subtropical jet. The polar jet is way up here. This is the subtropical jet. And that subtropical jet, which we have to look for a little bit higher in the atmosphere, is largely promoted by the contrast in the upper levels of the atmosphere, the temperatures in the tropics versus the poles, but it's upper levels of the atmosphere. And that's where we get this exhaustion of convective events out of the tropics that drives it. Now, if you notice, I just played this out there at about day 9. This is coming through something like this. And the big question is going to be, if that subtropical jet does in fact race through and keeps a ridge almost hugging the Rocky Mountains, we're going to get a lot of thunderstorm activity in the mountains. This is then going to dive, like we just talked about, these cascading storms over the top. This is going to support better rising motion throughout the whole of the jet stream running through here, along the U.S.-Canada border. And if it stays like that for a while, which is what the models are suggesting, this is going to keep the hottest, driest conditions south, really tucked away right in through here. And that's going to keep so much storm activity rolling over the mountains and then coming across here into the rest of the country. So let's go have a look at a couple things. Is that normally what happens in August, September, and October? Yes. See this right in through here? That is that subtropical jet when you historically correlate those ocean temperatures against the wind pattern. So what we need to do with this is understand where it could possibly go. Let's just go out there and look. This is the August, September, October outlook from the from NOAA. And the one thing I would have to just disagree with is the northern extent of this dryness. And what I'm thinking might happen here is that the flow comes through this area and runs over the top. Yes, we'll build cascading storms through here. We'll have near normal precipitation to the north, but I think this is too dry in this area. I am supportive of them forecasting the dryness here, at least climate or meteorologically. That would be common if we have this set up. Is that echoed in other models? Well, kind of. The latest European outlook, which came out at the beginning of July, you can see it's got normal precipitation here. It's got wetter conditions diving here, but it's drier in this area. And what I would tell you is keep the dryness far enough to the south, because if that jet comes in like this, there's going to be a lot of storms in this corridor running up over the mountains. I would also tell you that this is too dry of a signal. Plus, we're in the heart of the hurricane season. Who can forecast that for this area? It's near impossible. Let's go to another model. This is the National Multi-Model Ensemble. Again, you can see that wetter corridor, but I think that this area has been forecast too dry. I think there will be dryness here, but that might be the only limiting spot overall with this particular pattern. And I can finally give you the statistical approach to this from Columbia University. They don't show strong anomalies either way, but they do have the dryness in here, which I would have to just disagree with if that pattern does set up that way. So I wanted to give you that perspective. And then I wanted to show you this. This is just the newest outlook from the European model just for August. We just looked at August, September, October. This is now just August. And do you see how in this area they got better storm activity coming through? In fact, it even extends a bit farther to the north. I buy into this. What I don't buy into is this showing up drier. I think that there's going to be more storms in here than is being predicted right now. I'm talking about the whole of the Mississippi Basin and getting into the Ohio River Basin as well. And that would be the adjustment that I would put on this. A lot of storm activity in August if that subtropical jet races through and makes that turn. Okay? One last thing, international weather. We do have a couple of tropical systems to be looking at. Big typhoon here that's north of the Philippines, south of Taiwan. This one's heading toward mainland China. And then we have this cyclone here in the Indian Ocean. Now, we need to start watching the Pacific carefully, because sometimes these tropical systems, especially the Western Pacific here, make the turn north and go to Japan. And when they do, they get caught up here in the jet stream flow near the Bering Sea, North Pacific, and they can really be disruptive to our flow. As it stands, we think this one's going to come right here into mainland China and just produce a tremendous amount of rainfall. And over the next 10 days, look at India. Some places in here picking up an additional 4 to 8 inches compared to their average just in the next 10 days. And where the tropical system's coming in and what follows it in through here, we're going to be dumping a lot of rain. My friend and colleague Matt Reardon and Andrew Pritchard, we were talking about this yesterday. Initially, when this makes landfall, there's going to be about 120 million people that are going to be experiencing 4 to 8 inches of additional rainfall. And this goes right up here to the North China Plain. And you notice that if its rainfall gets into this area, they grow a lot of corn and beans here and other crops. So the North China Plain and Manchurian Plain showing up wetter in the forecast. So let's watch all of this. I do want to note, look how wet Europe is. We've had some major storm activity here. A big cool down in northern Europe. The heat was still on in southern Europe. Very hot in southern Europe over toward Turkey. But a lot of storm activity. This goes all the way across, over to Poland, Ukraine, Belarus, getting here into the Russian wheat belt. There's a lot of moisture coming into this area as well. All right, thanks for hanging out a little bit longer with me this morning. Just had a lot of stuff to discuss, and I'll talk to you again tomorrow. Thanks.